Okay guys, so in this video I'm going to take you through the first couple of sections of Chapter 5. We're going to spend all of Chapter 5 in KOM 267. I apologize for canceling class today. This migraine is not going away, so I'm going to try to do this video as quickly as I can so that you'll have a chance to work on some 5.1, 5.2 homework, and then we'll pick up on Tuesday. We'll start with any questions that you have about the first couple of sections, and we'll keep going from there. So just so you know, do watch the whole video, take notes, stop it, rewind it, whatever you need to do, because you are going to be responsible for this information, even if you didn't watch the video. So that's going to be a problem. So you want to make sure that you don't take it lightly. So anyway, the first couple of sections of 5.1, 5.2 are about two variable linear programming. So linear programming problems are problems where you take a lot of parameters. Like here's this situation, for example, on this first page, the Happy Cone Company wants to make two different types of ice cream cones, cake cones and sugar cones, both of which they have to process in the mixing department and the baking department. Manufacturing a batch of cake cones requires an hour in the mixing department, 2 hours in the baking department. Producing a batch of sugar cones requires 2 hours in the mixing department and an hour in the baking department. And each department is operated for at most 12 hours a day. So we've got all these constraints, all these parameters. Our goal, produce the ice cream cones, but we have these constraints. We need this such and such time to do that in each of these departments, and we have a maximum of 12 hours in the baking department, 12 hours in the mixing department that we can do that. So then the question becomes, what are some feasible combinations for cone manufacturing? For example, could we produce 3 batches of cake cones and 2 batches of sugar cones in a single day? Could we produce 4 batches of cake cones and 6 batches of sugar cones in a single day? So that kind of becomes our question, like what's possible, right? There's some things that seem obvious, like I don't think we're going to get 10 batches of each, right? Because even 10 batches is going to be, it's 20 hours in one of the 2 departments, which already, exceeds the 12 hours that we're allowed. But there's some other kind of fine tuning that needs to happen here. So what we end up doing is we end up thinking about what are our parameters and organizing them. Well, just like in Chapter 3, probably the easiest way to organize them is to build yourself a table, which I'm doing here. If you're not familiar with building a table in Word, I suggest that you play around with it some. It's going to be useful. You're going to be able to see what I'm clicking on the screen, so that's nice, which is also one of the reasons I want to meet in the computer lab. In this particular problem, we're talking about cake cones and sugar cones, right? And we also have some constraints about the mixing department and the baking department. Now, as you read the problem, it says manufacturing 1 batch of cake cones, right, requires 1 hour in the mixing department, 2 hours in the baking department. All right, well, so that relates right here. So we've got 1 hour in the mixing, 2 hours in the baking. Sugar cones was the opposite. So producing 1 batch of sugar cones is 2 hours in the mixing department, 1 hour in the baking department. So we've got the opposite happening here. And then we know that for both of these, we have to use up to 12 hours. Now, in previous iterations of this stuff, we want to use 12 hours, right? But this at most 12 hours introduces some variability into it. It could be 12 hours, it could also be 11 or 9.5 or 3, right? So there could be less than that. So I'm going to use the equation writer in Word, which I get to by just hitting Alt equals. You can also go insert equation, right? And it will come up with the equation tools. And I'm going to say what we need here is less than or equal to 12 hours. It's going to happen for both of these. I'm just going to copy and paste this down. All right, so the question, so that kind of organizes our information, right? So this is hours available, right? So, but the question was not this information. This just gets us kind of thinking about it. The question was, what are some feasible combinations for cone manufacturing? All right, so let's take this information and let's look at it a different way. Let's take this and let's consider it differently. So I'm going to kill this stuff off. Let's just delete this. Making a table is really easy. I just hate doing it over and over again. So I'm going to split these into 2 columns and call this cake versus sugar. And we wanted to know, right, like, so could we do, what was it, 3 batches of cake and 2 batches of sugar? Or could we do 4 of cake, 6 of sugar, right? What's possible? We've got the mixing department, the baking department. And so if we do this, we can look back and we can say, okay, if we need 3 batches of cake cones, then that's going to be an hour in the mixing, 2 hours in the baking, right? So we've got 3 times 1 over here, and we've got 3 times 2 over here. But we also have 2 batches of sugar cones, which is going to be 2 in the mixing, 1 in the baking, right? So we have to add to that, we have to add to that 2 times 2 and 2 times 1 in the baking. So that means that we've got, what is that, 4, 5, 6, 7 hours in the mixing department and 6, 7, 8 hours in the baking department. So far, this works, right? Let's add a little column over here to the right. Is it feasible? In this particular case, yes, we can do that, right? Because we didn't exceed 12 hours in either one of these departments. Over here, same kind of thing happens, only now we need 4 batches times that 1, 6 batches times that 2, right? So already we're exceeding our limitations because we've got 12 plus 4, which is 16 hours, which is not going to work, right? We can double check that over here, but we already know it can't work. So 4 times 2 and, nope, that's not right. Yeah, 4 times 2 and 6 times 1, right? And so the same thing is going to happen. We've got 8 and 6, and that makes 14 hours, which again exceeds. So no, this is not feasible. We could try other combinations, right? We could say, well, what if we did 5 batches of cake cones and a single batch of sugar cones, right? So could we do it that way? Okay, well, let's look and see what happens. So 5 times 1 plus 1 times 2. Okay, well, that's 7 hours. That'll work. We've got 5 times 2 and 1 times 1. Okay, so that's 11. That's 11 hours. So that's just under the wire. That also works, right? So that's no problem. So the only one we've found that doesn't work so far is this guy here, right? That one's the one that doesn't work. So the question is, do we want to just keep doing this, right? Do we want to just like keep